Hello, welcome to today's tutorial video. In this tutorial, we will learn how to visualize 3D log function in Python. So let's take a look at this function, z equal to log x squared plus y squared. If I visualize this function, I can get this result on the left side of this slide. And before I show you how to do that in Python, I want to share with you the logic behind this visualization. If you want to visualize this function, and you need to generate some data points. So first step, you need to generate the data points for x dimension and y dimension. Because if you take a look at the function, this function occupies three dimensions, right? X dimension, y dimension, and z dimension. So let's generate some data points for x and y separately in the first place. And when you have those data, you need to compose x and y to a surface. And then based on this two-dimensional surface, we're going to set up the z dimension. So this is how you set up all three-dimensional for the data points. Once you have the data points, then you need to create the 3D space in Python. And once you have the data, once you have 3D space, you're going to put everything together. Okay, so this is a logic I summarized for you to create this visualization. So now let me stop share the slides and go to Colab. So we're going to practice how to do that in Python. Okay, so first of all, you need two libraries, Matplotlib and NumPy. First of all, we need to generate some data points for x dimension and y dimension. We're going to use this. We're going to define x equal to NumPy length space. This helps you to generate evenly distributed data points for a certain interval. Let's set the interval with using 1 to 10, and I need 100 data points. And if your x is 100 data points, then your y should be consistent with that. And that y equal to NumPy length space 1 to 10 and 100. Again, they should be same. They should be consistent to each other. Okay, now we have the x dimension and y dimension. We need to compose two-dimensional surface based on only x and y. So we're going to say this. Capitalized x and capitalized y equal to NumPy mesh rate. So this is how you set up the surface. And in this function, we're gonna just pass small x and small y in here. And this is help you to define the z function, right? So we're gonna define capitalized z, and that equal to the log function, right? So we're gonna use NumPy log, and in this function we're gonna use x squared plus y squared. So x squared plus y squared. Okay, so this is how we set up the data and set up the function, and then we will move on to our 3D dimensional space. And we're going to define fig equal to plt figure. This is how you set up the fig size. Let's say our size would be 8 by 6. And then we're going to define x, and that equal to fig.add subplot. So this is how we set up 3D function, and we need a projection equal to 3D. Okay, and then we just put everything together. We're going to use x.plot underline surface because this whole log function is a three-dimensional surface. So we're going to use plot surface, and we're going to pass x dimension, y dimension, and z dimension in here, and then we're going to show the result, plt.show. Okay, let's run the cell. Okay, seems like we have an error, and So here's a mistake in here. We need to change that small x to capitalized X. We need the composed value instead of the original value. Okay, so let's rerun the cell. And you can see here, this is our surface, right? This is a log function in 3D dimensional view. Okay, so if you want to add some color story in this function, you can do this. You can go to the plot surface and change the C map. And this will add some color, sequential color to this surface. And we're gonna go with HSV. And now you have very colorful log function showing in this 3-dimensional space. Okay, I hope you enjoyed today's video, and I will see you next time.